Hello class and welcome to week 3. For this week and next week you have only one exercise, but the point is this exercise needs a little bit more time, so please make sure to listen to this video several times. I'm trying to explain some kind of points here, so you are making sure that you are on the right way to go with this exercise. Okay, for this week we are learning about the Herfindahl index. If you like to understand more about this index, just follow this link and you can see just you need to only review page 14 till 16. The Herfindahl index is an index to measure the competitiveness market. Basically, if you are a manager of the hospital, any kind of other providers, you need to know the location of your company, of your hospital, and see based on this location which strategies you need to go with that. Otherwise, you're gonna lose a lot of money. Okay. I'm not going to discuss about the Herfindahl index, but I would like to to know that okay, this is the index that is important, and for that reason I bring it here for this class. For this week we are not going to use t-test. We have 3 groups, and the t-test is good for 2 groups. Not when you have 3 groups, you can go with ANOVA or chi-square. I will not explaining here why ANOVA or chi-square. I like you to search and know more why, which is a short answer is okay. ANOVA is go with non-parametric test, and chi-square is a non-parametric test. The main difference between parametric and non-parametric is that when you are going with parametric tests, you have a normal distribution, and the normal distribution is a very bell shape curve. We can show you here later. And the non-parametric test is accurate when you are working with non-normal distribution of data. Okay, let's review the question first. Okay, for this question, for the first question, you need to compare the n observation, mean, and standard deviation for high competitive markets, moderate and low competitive markets. And the variable is almost the same variable you work in week 1 and 2. I believe we have maybe 2 or 3 more variable here. Let's see. This is week 2. We had 13 variables. We have the same variables here. We just only added Herfindahl index. Okay, the point here is this Herfindahl index here, this is the categorical variable 1, 2, 3, but here this is the real index. I will show you later. Sorry, what is different between these two? You don't need even to know what's the difference between, because this is the continuous variable, right? If you go with the density curve, you can understand the type of variable. So don't bother yourself for now. Don't focus on this. Okay, here this is the codes I copied here, and I'm gonna copy this. I'm gonna put this all of this code in the class. You don't need even to copy. You can just download the R script and then try to change. The first things you need to do is just we learned here from week 1 and 2 that okay, always you can use the log file, right? The log file is show you all of the console here, RStudio consoles, and then you can see it later. I like to add one more point here. Some of you ask me how we can and change the font here in the RStudio. If you go to the tools here, you can see global option and here appearance, right? I'm gonna go and with 10 so you can watch this video much easier. Okay, I think this is good. We can just maybe go with 12. Let's go with 12. Okay, this is 12. Okay, you can see it's much better. The data set is still the same data. I didn't change it. If you download this data one time, this is okay. You can just go with this data set. This is the same HMGT 400 hospital. This is the CSV file. And like any other weeks, you need to go with installing the package. And then you need to introduce this package to the R. Otherwise, you are not able to group your file like this. You are not able to go with summarizing command. You are not able to get this command. You are not able to go with most of this code. So please make sure to install this. And as I explained, this video is for Windows, but except this part, all other part is the same between Windows and MacBook. So if you are using the MacBook, the only changes should be this part. So I'm gonna show you in the week 2. I was explained someplace. I think it should probably see here. Okay, not here. Okay, I'm explaining here. I believe it was in the, let's see, instruction. UMUC. Okay, I believe it's here. Instruction. Okay, I explain here. Okay, if you are working with MacBook, create a folder and document. The address should be document/UMUC and then the name of the file, right? This is the point. Okay, let's go with codes. You know, for this accessor, the only things you need to do is just change this location here. Make sure to change this. I say okay, C/UMUC victory exercise .txt. Some of you save it as a CSV file. This is incorrect. So if you go with a CSV file, you are not able to see the decimal. Make sure you are writing it text file. Okay, usually it's better to keep all of the log file as a text file, or you can just open with any package, even in your email address. This is text file and this is CSV file. The address you are using for here for the sync command is exactly like the address you are using for the reading the file. So I don't need to explain one more time how do you read this file, right? You know that you can go here and then import from Excel. So if you are a little bit confused about it, please make sure to watch week 2 video. Okay, for this the point is the benefit is not in the data set, so you need to generate that variable here. So first you need to change this location, your computer. Let's go step by step. Okay, I'm doing something wrong here. Go with this, change this in your computer. If you already have the UMUC, just add it week 3. If you are working with 2, you can just change that route to the week 3. Then make sure to install the package. When you install the package, make sure to just read that package, introduce that package to the R, and then go with this this command, generate hosp, the hospital data. This data has here 33,000 observation with 28 variable, I believe. So because we need to generate. Let's see. Okay, I'm gonna install this package first. Okay, I'm gonna read this, see if this is a right path. You will see this. Otherwise you're gonna receive an error message. Install package DPLYR, run this, and if you are in the middle of RStudio, you're gonna receive this message, so please say yes. And it's installed. Where is that? Okay, here. It's gonna install in this package, so it's installed, and when it's finished, say okay, package successfully unpacked, and okay, MD5 sums check. MD5, we don't care about this. You don't need to take care about this, because MD5 is kind of security of system. It's for just zipping something. And then you need to read this library DPLYR, right? This is it. Okay, and then let's read this file. And this file located in drive C of my computer. Okay, the file here is 27 variable, right? Let me read one more time. 27 variable. Okay, and the name. Every file you are reading in R, you need to make sure that how many variable is there. And okay, it's a routine, you need to do it. This is all the variable you have it here, 25, 26, 27. And as I said before, I don't know I said before, no, but as I believe I explained in week 2, the benefit is not part of the variable. You need to generate that variable. This command shows how do you want to generate a new variables. Usually when you want to generate new variables, I say in this command, okay, go with hospital, HOSP data, $sign is okay, benefit, it means $sign benefits mean generate a benefit variable in the HOSP data set. How generates that variable? Okay, hospital. Okay, I mean here I say okay, use the total revenue and total hospital cost and generate this variable, right? So this, if I run this command, see, should be 28. This is 28. Okay, I'm also need to generate something else. If you look at the exercise here, they say the Medicare ratio. I believe in some place we ask you to do that. Medicare ratio. Okay, what about the number of Medicare, higher competitive markets? Okay, here, ratio of Medicare on Medicare. Okay, you need to generate that variable too. I'm generating this. Right, I have 29 variables here. Okay, this is the Herfindahl. The Herfindahl is a categorical variable. I'm gonna ask RStudio to group by hospital based on the Herfindahl, right? See here, you generate this variable, and if you go with my table, let's say tab this variable. Let's see this. Let's say table Herfindex, Herfcat, right? It doesn't work here. Okay, see, usually you can see table HOSP, HOSP, $sign, Herfcat. It means 0, 1, 2. I explain here, right? 0 is high competitive, 1 is moderate, and 2 is low competitive. Okay, we want, based on this command, you can see all of the mean. As I explained in week 2 exercise, this command has 3D, maybe, let's see, one command is summarized, one command, this is the data set. I generated this data set here. This is the bed, mean of bed, use hospital means to get the mean of bed, and then if this is a missing, remove that. A few of you had some question here. Make sure to block or to highlight, to select. I'm explaining a different word to make sure this is, you need to select all of them together, otherwise if I select all of them together, you will receive this result here. Otherwise, let's try different way. Let me select a few of them. Okay, see this message shows you that okay, you did not close the code. If you want to close the code, you have to select all of them and press run, right? Okay, there's some problem here. Okay, this is completely new for me even. Okay, got this point, because from here I actually didn't recognize this is a new file, new command, so just go ahead and it started working in the previous command, so I just change it. I explained week 2, right? If you want to see all of these numbers, see here 4 more variables cannot show here because of this. There's 2 ways to see that. You can extend this console. Let's see, okay, here if I can see here all of them, there's still 2 more. The other way is just go ahead with this global option. Let me reduce the font size. I'm gonna go with font 10, and then here, okay, I can see all of them here. So I'm gonna go back to the previous font just for you to see better here. Okay, this command gives you the mean, and we can go with the standard deviation. Select and run, see the standard deviation. So I don't explain how do you want to do that. You can just change the tools, or just go ahead with that, or just extend it to the very end. And I believe you have to see here. Okay, what's the message here? Okay, usually when you receive a message, repeat the code. If you get the same message, so it's something, you are doing something wrong. Otherwise, this is just maybe the machine error or something like that. Okay, for step 8, you need to generate 2 datasets, right? Maybe 3 datasets. High, competitive, moderate, and low. Okay, generate 3 datasets here. The first datasets explain, okay, if Herfindahl cat category variable is 0, is 1, is this is 2, right? Okay, I'm going to generate these 3 datasets here. And from this step, let me remove this. Okay, I'm gonna go ahead with all of this observation, right? This is observation for Herfindahl index. There are 219 hospital in this. Okay, I can call it maybe 10, 1, 10, 2, 10, 3. I will change it later for you. I'm gonna just go ahead to have a shorter video, and then we can see for the moderate, right? We have 1332. Okay, let me explain you this command. This is my table command, this is the data set, and this is the name of variable. This command generate this, right? And for the summary, you can see what RStudio generated. Okay, you can go ahead with this for observation for the low competitive hospital. See, there are 1479. all of these observed numbers is good for this part, only for this table. We didn't talk about the ANOVA test till now. It's very easy. You can just here, okay, yeah, it was here, right? Here I have 219. If you are using two monitors, you can just, in one monitor you can see RSD, in the second monitor you can go ahead with table. See here, you can just add 219. The mean was, okay, I did something wrong. Okay, the mean was here, right? Or was it was the mean, right? This is the standard deviation, and this is the mean. The mean is 365. Copy. You can just copy and paste here. Okay, Control V, right? Just keep only one decimal is enough. And then you can see the standard deviation here, 365. Is it standard deviation? Yes. And what is this? Oh, this is the standard deviation. This is the standard deviation. This is the mean. Okay, I made a mistake. This is mean. This is mean, right? And this is the standard deviation. Copy, paste, right? You can just go ahead for the other part of this. This is for high competitive, this is for one was for moderate, right? See here, I explained here, always look at this moderate. This is for moderate. Standard deviation is here. This is the mean, right? This is the mean. This is the, okay, standard deviation is here. And for low competitive market, this is the standard deviation. Okay, let me go from the first. This is the mean. And this is the standard deviation. Okay, you also need numbers. The numbers is here, 219 for the bed, and I believe this is it, 132. This is hospital bed. I think it was 140 something. Okay, 1400. Hospital bed here, 1479. Just copy here. Okay, make sure to fix this and only keep only one decimal here. I'm gonna remove this. I'm not going with a 4 decimal, and you know you need to round this. You know how to do that. Okay, you can use a smaller font and it's gonna be okay, right? Okay, yeah, it's okay. Can double click and fix this. Okay, let's go back to the exercise. And the final steps, I mean maybe close to the final steps. Okay, this is test for ANOVA, right? Basically this test, okay, let's run this and see what's the result for this test. This test shows you that okay, and the mean, this is the p-value, right? Let me copy this here for you and then explain on the table. the p-value is less than 5%, right? When the p-value in the ANOVA test is less than 5%, it does mean that at least one of these mean is different. At least one of these mean is different. It doesn't mean which of them is different, but shows that, okay, there is significant difference between number of hospital beds between competitive market, moderate market, and low competitive market. And based on the means, you can see, okay, the moderate competitive market more likely to have higher bed. This is the point for here. Let's run some other tests. I'm looking to one of them that is not significant. I'd like to show you. Wow, okay. Is it not significant? Okay, here. We compared here number of Medicare days, total hospital Medicaid days. You know, this is 0.7673, right? Based on this, you can say, okay, between all of the three hospitals, there is not a significant difference in the hospital Medicaid days. This is the way you can go with that. And maybe one of you gonna ask, okay, what is this asterisk here? Usually our studio give you some guideline based on this. Okay, if there's 3 asterisks, does mean less than 1000. In usually we go with this, right? 1 asterisk is less than 5%, 2 asterisks is less than 1%, and 3 asterisks it does mean less than 1000%. So it does mean we are using 0.1 only for the economic paper, so we don't need to be worries about this. Okay, let's go for the other part. What's the other part of the exercise? Okay, use the here use the density curve and compare hospital costs and revenue between the markets, right? For this you need to generate a data set for revenue, right, and the cost. This part shows you how to generate this data, and let's plot this data. This is all part of the plot, right? Let's run this and see. This is the plot. Let me run this one more time. Can have a better plot here. If you receive this kind of message, just ignore that and try to run the code. Here you can see this is the blue one is a cost and the red one is a revenue, and you see there is a little bit higher cost than revenue, but they are in the same shape. Also there is a tail here. I can call this outliers. If you remove the outliers, the distribution is almost normal distribution. So the ANOVA test is a good test for this. Otherwise you need to go with the chi-square test. And okay, the same things for this is the last part. What's the last part? Okay, this is for this plot. What is the impact of being a high competitive market on hospital revenue and cost? Do you think is it being high competitive? Okay, let's go with this part. You need to generate variables first and then go with the subset data. This command generates subset data for high competitive, moderate competitive, and low competitive, and then test these two together, right? You learned about the t-test. In this t-test, I compare the high competitive market with moderate competitive market. Can you remember I just say here I mentioned that, okay, if you go with the ANOVA test, you are not able to see which of them is important. So for that reason, which of them is significant. So I don't know, is it because of this and this, for example, or because of this one and this one, or because of comparing this one and this one? So for that reason, we need to go with t-test. Here we learned about t-test in last 2 weeks ago. The t-test has t-value, degree of freedom, and p-value. Also gives you some information on means, right? Here the means one, mean x is 52.13 and mean y is 1, or you call it y, right? Y is a French name for this. 41.0. And here the 52 is the Medicare discharge in high competitive market, and 41 is in the moderate competitive market. So one of the students asked me last week, okay, if the value of t increased, it does mean, is it more significant? I want to say no, it doesn't matter. It's matter that just in terms of heteroscedasticity. We are not talking about heteroscedasticity in this class, but usually when your data is when you are working with heteroscedastic data, so you can see very big t. It doesn't mean always that having a very high value for t is a positive thing. No. Okay, for now, ignore any kind of the t value. You know how do you find the t value, how do you find the p value using the t student table, right? If you know, let me know, I can post something about that. But look at the p value. The p value is 2.2 e power minus 16. It does mean it's really it's something like this: 1 2 3 4 5 6 7 8 9 10 11. Okay, this something like this, 22. It does mean, okay, this is very a small number, so I don't need to consider this, only go with 3 or 4 decimal. It's 0, right? It's 0, so it does mean it's really highly significant difference between Medicare discharge ratio between high competitive and moderate is it different? What about the high competitive and low competitive market? So go ahead with this. Again, the same result here. There is a very high significant impact here. So the conclusion for this is, as long as you go from the high competitive market to moderate competitive market, you're more likely to have lower Medicare discharge ratio. Or as long as you are moving from high competitive market to the low competitive market, you're less likely to see higher Medicare discharge ratio. Let me repeat one more time. As long as you are moving from high competitive market to moderate competitive market, look at the mean. High competitive is 52, moderate is 41. It does mean the high competitive market more likely to have more Medicare patient, and here the high competitive market more likely to have more Medicare patients compared to the low competitive and even moderate competitive. This is the point. You need to report that. And here this we compare here Medicaid, right? The Medicaid here probably is gonna have a different, okay, the same result here. You can explain that same here. And I believe it's almost the end, and for here we are going to see to compare. I believe we explain which part is this. Okay, what other variable? Let's discuss. Okay, I believe here I try to explain to you how to work with eliminated subset data. Let's see. Okay, here, okay, oh, I see. Here I compare the discharge ratio between 3 different markets, right? This is the 0 is really high competitive, lower and moderate. It was here, right? Is it, am I correct? Let's see. Okay, 0 is high competitive, moderate competitive. Okay, I see. In the high competitive market, you're more likely to see higher Medicare discharge, and we tested before, right? You can remember that a few moments ago. And here I'm gonna go ahead with the Medicaid, the same thing. Make sure to select all this part and this run this. Okay, this is Medicaid, right? It's almost the same distribution. Ignore the warning. Density of data cost. I'm gonna compare the density of data here, right? We did it before, but let's do it one more time. And here, this is the density of your data, cost and revenue. I believe we repeat one more time. Okay, the last point is, if you have an organized, let's save it, if you have an organized code, if for any reason you lost your codes, you lost your file, it's very easy, right? You can just select all of this, click on run, and it's gonna go ahead and do everything from the first. You also can see, okay, it showed me that it's installing the DPLYR package one more time. This is okay. If you click here, you can see your file. Basically, you can just see your file that are in the memory of the RStudio. But if you want to see, let's see the result for this. So this is exercise 3, and you're gonna have something like this, right? This is all the variables here. The other way to generate the codes, because you know the RStudio only the log file only show you the result, right? Don't show you any codes here. So maybe you're gonna be confused. To do that, to have more detail on your codes, you can just run the codes here. Start from here, right? And let's say step 2, run this code, and you can just copy here. You can just select this, right? You can just select this. Let me just enter. I'm gonna run one more time, otherwise. Okay, just copy this, right, and paste in, maybe in just kind of notepad or something like that. You can just paste here, right? If you paste here, you can see your comment here. This is the good things about copying and pasting. So you can go step by step and paste your code here, right? You can just copy and paste here. Okay, this is the week 3 exercise, and this exercise is for week 3 and 4. I'm sorry that it takes so long, almost 38 minutes. And I try to explain more details on this exercise. So hopefully you don't find any problem. If you find some problem, so don't hesitate to let me know. I'm always be glad to help, but please make sure to watch this video several times before sending your question. I appreciate all the students that they are working together or just helping other classmates. This is what I would like to see more. Thank you, class. Have a good weekend. Have a good day, and okay, hopefully the government shutdown doesn't have a lot of impact on the class, hopefully. So let's see. Thank you.